Hey guys, welcome back to TSI Review Part 6 Probability. Alright guys, so probability will either be a fraction or a percentage. When we talk about probability, we tend to get an answer that it will be a fraction or a percentage. That's why I went ahead and wrote these common fractions, so that you guys could go ahead and make those connections if you didn't know that information. So, let's talk about percentage though. How do we get percentage? Quite simple. All we simply do is we move the decimal 2 to the right. So 1/2, which is equal to 0.50, is actually 50%. 1/3, we move decimal twice, is 33. But since it's repetitive, that means it keeps on having 0.33. I'm going to write that so that we could be aware of that. 1/4, 0.25, 25%. 0.20, 20%. 0.16 with a 6 repetitive, that means it's 16.6 repetitive percent. 0.125 would be 12.5%. 1/9, which is 0.11 repetitive, would be 11.11%. 0.10, very simple one, yay, 10%. 0.09, 9.09%. Cool. These are the common fractions that you will most likely see. Now, those are the bases, I should say. For instance, 3/4, you might see this as a possibility. 3/4 is exactly what? Well, it has a base of 4. So that means 1/4 is 0.25. I have 3 of them. 0.25 times 3, 0.75. Or 75%. 2/5, the fifths are 0.20. So if I have 2 of those, that would be 0.40 or 40%. Just making sure that we know how to kind of get those percentages if they show it to us like that. All right, so let's go ahead and talk a little bit about probability. You probably haven't seen probability in forever. You with me? And you might feel a little bit uncomfortable trying to do some of these questions, but trust me, trust the system. Write things down like I write them in this video. Hopefully that gets you to the correct answer that you need to be successful. So, like we mentioned, probability is a fraction. We have the desired outcome. This one usually most people get that part correct. The part where people mess up a lot is the bottom. Sometimes they don't choose the right data that messes them up. So I'll show you some couple of ideas that I'm going to be doing so that you can eliminate not choosing the right population. All right, so let's get started. Here's the first problem. Ooh, the famous bag of marbles. In this case, they're beads. A bag contains beads of different colors: 12 red, 15 yellow, 3 green, and 20 blue. One bead is randomly pulled from the bag. What is the probability that the chosen beads is yellow? So we want to choose a yellow bead. How many yellow ones do I have? Obviously, there is 15. That's quite simple. Most people get that part right. Now, relevant population. What are we talking about here? This is where you got to keep in mind the information to tell them one bead is randomly pulled. Where are we pulling this bead from? From the bag. So, what is in the bag? All these beads. So guess what? We're gonna have to go ahead and add the 12 red, 15 yellow, 3 green, and 20 blue. And if you add them, it's equivalent to 50. All right. Now, most likely you will not see this answer. Why? Because most answers are simplified. So let's go ahead and simplify this. We've been practicing our bell ringer, so hopefully you are able to do this by now. So they're both divisible by 5. So 15 divided by 5 is 3. 50 divided by 5 is 10. So this is equivalent to 3 over 10. What is that equivalent in percentage? 30%. All right. So let's go ahead and look at the next question. Same bag, different question. What is the probability that the chosen beads is not yellow? So we want to choose a bead that is not yellow. So it's the same bag that we did in the other question. So we know that there is 50 beads, but how many of them are not yellow? Well, there's 15 yellow. So we're going to subtract 15 from the 50 that we have in the bag. That is equivalent to 35. Beads are not what? Yellow. I'm just writing this down so we can make sure that, hey, we understand what that number means. Right? 35 beads are not yellow out of the 50 total that were inside the bag. Reduce once again. What can we reduce this by? 5. So 37 divided by 5. 35 divided by 5 is 7. 50 divided by 5 is 10. So this is equivalent to 7 over 10. What is that in percentage? 70%. Right, so I think you guys will do pretty good on these. The ones that where people mess up a lot is when they're given a table. So let's look at this. So let's examine this information. All right. What is this table giving us? Passed the TSI. Cool. Did not pass the TSI. Oh, so did the review. Ooh, how many of y'all did your review? How many of y'all are doing your review? Please be successful. Did not do the review. Wah. Right, so we have this information. So let me ask you a couple of questions that you should, when you look at this data, you might want to ask yourself. When you look at other data, you might want to ask yourself more questions. For instance, in this case, I'm going to ask myself, how many passed the TSI in total? Well, in total, I have 23 that did the review and 2 that did not do the review that still passed. That is a total of 25. How many did not pass the TSI? Oh, look at this. 25. How many students did the review? Well, did the review. We had 23 that passed it and 6 that did not pass it. Total of 29 people who did the review. How many took the test and did not do the review? 21. Now these numbers are good because guess what? These are our total population numbers that we're going to be using. All right? These are the population numbers we're going to be using. Okay. What am I basically trying to tell you? Hey, those are the population that we're going to be using. So when we look at the question, one of those numbers will be our population. So let's go look at the questions. If one of the students who took the review is chosen at random, what is the probability the student passed the TSI? If one of the students who took the review is chosen at random, This is the key right here. They're telling you that that student took the review. How many took the review? A total of 29. Out of those who did the review, right? How many of them passed the TSI? 23. Right? So if one student who took the review is chosen at random, what is the probability that the student passed the TSI? 23 out of 29. That would be my fraction. Now, what would be the percentage? Mr. Bendu, you didn't give me that fraction. You didn't give me that denominator. I have no clue. Well, this is one simple way that we guys could go ahead and do an estimation. 29 is close to what? 30. Yes? So 30 times 3 gets you close to 90. Right? So then I'm going to multiply 23 times 3. And that's going to be 69. Right? And I'm doing this is an estimation, okay? And I'll explain to you why I'm doing this. So I don't know what this is in decimal, right? So I'm going to estimate 69 out of 90, right? So what's my answer? Well, for sure, it's more than 69 kids. All right. Next question. What is the probability that the student picked on random did not pass the TSI? Let's look at that situation again. What is the probability that the student picked on random did not pass the TSI? So we already know did not pass the TSI. How many kids did not pass the TSI? Six that did the review, 19 that did not do the review, for a total of what? 25. That would be my desired outcome. Right? Now, population. Was I specific in this population? No. So the question is how many total students we have? Well, what's 25 plus 25? 50. There's a total of 50 students. I'm going to put 50 here. Now, can we simplify? In this case, we can. 25 divided by 50. Both divisible by 25. 25 divided by 25 is 1. 50 divided by 25 is 2. Equals to what? 1/2. All right, so 1/2. What's that in percentage? 50%. Either your answer is 1/2 or 50%. Hopefully this helps you. Have a great day.